Okay, so we're now going to go through an alternative method of answering part E here, and we're going to be using the table method. So all I've done is I've copied my table from part D and I've put it right here. So the way I created this is in part D. So go back and watch part D if you want to see how I created the table. And I actually think that for part E here, using the table might actually be a bit easier than doing it on the network. And another advantage of the table is that we're not constantly redrawing on our network. And imagine in an exam where they've only given you one network and you're constantly redrawing on it. It would become very messy very quickly. So therefore, the table method has a big advantage in that sense because, you can kind of have it off to the side and you can just change the table without having to constantly rechange the network. Okay, now let's center ourselves. Let's remember the aim of the game. The aim of the game is to turn 35 weeks into 31 weeks for the minimum cost. We want to turn 35 weeks into 31 weeks for the minimum cost. How can we do this? Well, let's at the moment look at our 35 week. So that is this right here. This is our critical path. So it makes sense that the first thing we want to do is try to reduce this 35 pathway as much as possible. Now, that means we're going to be reducing D, G, and K. So let's come over here and let's write D, G, and K. Now, we don't want to reduce it by too much and waste money, so let us take it really slowly and just reduce each of these only by one each. So let us rule this up now. So what I'm going to do is reduce D, G, and K from each of these pathways only by one. And then we'll see what my 35 will turn into as we go through it. So let's quickly come here and let's go through it. So for my first one here, as you can see, I've only got a G. So that means I'm going to reduce 29 to 28. For my next one, I have a G and a K, which means I can reduce 34 to 32. For my next one, I only have, I've only got a K there, so that means 33 will become 32. For my next one, I've got a D and a G, that means 30 will become 28. So this one here will become 28. For 35, I've got 1, 2, 3 of them, so that means this 35 will become 32. And then for this one right here, I've got a D and a K, meaning 34 will also become 32 here. So as you can see, my new critical path, so my biggest number now, would be what? It would be 32, 32, 32, 32. So now I just need to reduce one more to get to that 31. So now I would look through these ones right here. So I've really got my eye on now. This one, this one, this one, and this one. Now, do they share any of these highlighted letters? Now, here I've got C, C, this doesn't have C, this doesn't have C. Here I've got G, but this doesn't have G. This has G, this doesn't have G. Here I've got K, 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 and K. Now, do they all have Ks? This has got a K in it, this has got a K in it, this has got a K in it, and this has got a K in it. Now, how much is a K? K is $4,000. Now, that's a lot of money. Now, if I reduce it by K, sure, they'll all come down to 31, but is that the cheapest way I can do it? Is there another way that I could reduce them all by one and it not cost me $4,000? Now, this is where it gets tricky. This is really tricky now, being able to look at this and being like, all right, is there another way I could reduce them all such that, I get to 31, but I can do it for cheaper than $4,000? Because hopefully you can all see that all of them have a K in it. So I could reduce all of it by K, but that would cost me $4,000. So is there a cheaper way I could do this? Well, and again, this is tricky. This is recognizing now that this has a G, this doesn't have a G, this has a G, this has a G. So we don't care about that one, my bad. This has a G, and this has a G in it, but this doesn't, and this doesn't. But this has a H, and this has a H. So what if I reduce both G and H? Well, if I reduce both G and H, this is G, this is H, it'll only cost me $3,500, which is cheaper than $4,000. So by reducing both G and H now, so I could reduce both G and H by one, I'm actually going to save money because it's going to be cheaper than $4,000. Now, you could kind of go through other ways of going about this and see if there's a cheaper way again, but this is going to be the best way to go about it. So now, if I do this, so if I reduce G and H, and remember, we only really care about these circled numbers here. So this 32 will become a 31 because it's got one G. This 32 will become 31 because it's got one H. this 32 will become 31 because it's got 1G, and this 32 will become 31 because it's got 1H. And just like that, I've gone from 35 to 31. That is now my minimum completion time. Remember, these numbers don't really matter because they're not going to be bigger than 31. So that means, what have I done here? Well, I've reduced D once, I've reduced G twice, I've reduced K once, and I've reduced H once. I didn't reduce C at all. So I'm going to get 0, 1, 2, 1, 1. And that is going to be my answer. Now, as I said, that's pretty tricky, but I think actually the table method is a very good way to approach this, which then leads one to maybe assume that maybe in part D, we should have done the table method because then it leads on to part E. So again, lots of things to kind of keep in mind here as you're working through it and trying to think of the best way to go about it. All right, I'll come back and now we'll talk through the examiner's report.